My name is Norfari Iman binti Ahmad Nazri.
Hi, my name is Khairunisa binti Muhammad Nasir.
Assalamualaikum, my name is Wanda Batrisha binti Muhammad Zaidi.
My name is Nur Ain Sofia. Today we are going to go through subnetting IPV4 addressing using Cisco Packet Tracer. I will guide you on how to do the part 1 step 1 for this first 3 step ABC. So the first thing we have to do is to set up minimum of 50 host IP addresses for LAN-A network. So as you can see, I already set up the devices. So we need to set up the minimum of 50 hosts for LAN-A. So let's just put some notes here. 50 hosts, and then for the second subnet, which is LAN-B, we're going to need to set up minimum of 40 host IP address. Hosts, and then it required to at least have 2 additional unused subnet.
Now we move on to question D. Answer the following question to help creating a subnetting scheme that meets the stated network requirements. So in question 1A, how many host addresses are needed in the largest required subnet? So since this project required us to build a minimum of 50 host IP addresses, so the largest required subnet will be 50 hosts. Next, question 1B, what is the minimum number of subnets required? So the first subnet is the LAN-A, the second subnet is the LAN-B, and 2 unused subnets are for expansion. So there will be 4 in total. Then question 1C, the network that you are tasked to subnet is 192.168.0.0/24. What is the /24 subnet mask in binary? So the given prefix is /24 with the subnet mask 255.255.255.0. So we can convert this prefix using the subnet mask using the calculator to binary, and we can get 255 convert to binary, we'll get 8112341234.255 convert to binary 8112341234 point, once again 8112341234, then 0 that we convert to binary will get 08. So 12341234. So that's the answer for question D.
Next, I will discuss about question E. The subnet mask is made up of 2 portions, the network portion and host portion. This is represented in the binary by the 1s and the 0 in the subnet mask. Question 1D. In the network mask, what the 1s represent? The 1s is represented for network portion. Next, question 1E. In the network mask, what do the 0s represent? These are represented as the host portion.
So I will guide you on how to answer these F questions, which we need to do 3 things. One is to convert the subnet mask in binary to decimal subnet mask to decimal form, and then we're going to determine how many number of subnets, and then we're going to determine number of hosts. So here I already did one example. How I got this answer is just simply by converting these binary numbers to decimal. So first thing first, we can copy this first byte that contains 8 of ones, because IPV4 have 32 bits, so 8 times by 4 is 32. So I already copied it, and then we're going to convert it. 111148 equals to 255 in decimal, because there are 3 bytes of 111 of 8, so 8 of 1. So I already did 255 3 times, and then to determine the decimal number for this host bits is just copy and then paste it. So the decimal number for this binary number is 1 to 8. So yes, we already did that. So 255.255.255.1 to 8. Because this thing is repetitive and it's just the same thing, I'm going to speed up the process. So next we're going to determine the number of subnets. So there are already a hint given here, which is number of host bits to the power of 2 defines the number of hosts per subnet. So the number of subnet bits, so we're going to find the number of subnet first to the power of 2. So this one is subnet bits, and the rest, which are 0, is the host bits. Because there are only one of this one among these all 8 bits, so we're going to power 2 to the power of 1, because there are only ones here and 1 represents subnets. So 2 to the power of 1 is equal to 2. So same goes to the question number 2, which only have 2 for these host fields, and there are only 2 of ones here, and the rest are 0. So 2 to the power of 2 will be 4, and it goes by just like that. It increases each time we go down to every question, because every question have increment in the one value, in the 1 bits in the host field. Next, we're going to determine the number of hosts. So the number of hosts that was given in here is number of hosts per subnet will be subtracted with 2. So it's exactly just like how to count number of subnet, but instead we are going to count the 0 in the host field. So because there are only one here and the rest are 0, which means there are 7 0 and only 1 1, because 1 byte is equal to 8 bits, right? So to do so, we're going to power 2 to the power of 7, because there are 7 0. And then 2 to the power of 7 is 1 to 8, and this is not the number of hosts yet, because we need to minus 8 with 2. So 1 to 8 minus 2 equals to 1 to 6. So this is the number of hosts. So next question is the number of hosts for prefix /26. There are 2 zeros, which means there are the remaining of 6 zeros. Sorry, there are 2 ones and the remaining are 6 zeros. So that means it is 2 to the power of 6 equals to 64. And again, this is not the number of hosts yet. We need to minus with 2, and then we'll get the final answer, which is 62. So this is the number of hosts. So we're going to do the next question. I'm going to fast forward the next So as you can see, how to calculate the number of hosts and subnet is the difference is the number of hosts we need to minus with 2, and also the number of subnets that gets bigger while the number of hosts gets smaller. So that's how to do this question F.
Next, question 1G. Considering your answers above, which subnet must meet the required number of minimum host addresses? So since our network is required to have minimum of 50 host IP addresses, the subnet mask that meets the required minimum address is prefix /26 with subnet mask 255.255.255.192 with the minimum of host address per subnet is 62. And also /25 with the subnet mask is 255.255.255.128 with the minimum host address per subnet, which is 126. So considering your answer above, which subnet mask meets the minimum number of subnets required? So since we need to have 4 subnets in our network, so the prefix that suits the minimum number of subnet required is /26. With this subnet mask 255.255.255.192. Also a prefix /27 with this subnet mask 255.255.225.224. And also including the prefix /28 with the subnet mask, which is 255.255.255.240. Also /29 with the subnet mask 255.255.225.248. And lastly, it also includes the prefix of /30 with the subnet mask, which is 255.255.255.252.
Considering the answer above, which subnet mask meets both the required minimum number of hosts and the minimum number of subnets required? So the network is required to have a minimum of 50 host IP address and 4 subnets that we use. And the subnet that meets the minimum of number of hosts and the number of subnets is 255.255.255.192 because they have a suitable number of subnets and number of hosts per subnets, which is 4 subnets and 62 hosts per subnet. When we compare to other number of subnets and number of hosts per subnets, we prefer to they are smaller than the expected minimum host IP address and subnets. For example, for prefix 27, the number of subnets is 8, but the number of hosts per subnets is 30. So they are not suitable for the minimum of 50 host IP address and 4 subnets that we used. So moving on to the question 1G, when you have determined which subnet mask meets all of the stated network requirements, derive each of the subnets, list the subnets from the first to the last in the table. Remember that the first subnet is 192.168.0.0 with the chosen subnet mask. So in this table we are using 192.168.0.0 for the subnet address, and the prefix is for all subnet address is 26, and the subnet mask is 255.255.255.192, and the subnet address is 192.168.0.64 and 192.168.0.128 and 192.168.0 and 0.192. So we are choosing this subnet address.
Next, we will discuss about step 2. Fill in the missing IP addresses in the addressing table. Assign IP addresses based on the following criteria. Use the ISP network setting as an example. A. Assign the first subnet to LAN-A first. Use the first host address for the customer router interface connected to LAN-A switch. Second, use the second host address for the LAN-A switch. Make sure to assign a default gateway address for the switch. Third, use the last host address for PCA. Make sure to assign a default gateway addresses for PC. As we know, from customer router to LAN-A switch is used for gigabit 0/0. So first we need to go to subnet and then copy first usable IP addresses, and then we paste at the gigabit 00 IP address on customer router. And then for subnet mask, we need to copy the same row as the subnet mask at subnet, and then paste on the subnet mask addressing table. For LAN-A switch, copy for IP address and then paste on at the same IP address. Subnet mask, we still use the same subnet mask, and then we paste. For the default gateway, we need to paste the same as IP addresses at gigabit 00. Copy and we paste at default gateway. Next, for the PCA, we need to copy for the last usable IP addresses, the same row as the first usable IP addresses, and then paste on the PCA at addressing table. Next, for the subnet mask, we still use the same subnet mask, and then for the default gateway, we still use the same as gigabit 00 IP address. Now we are doing for the B, which is assign the second subnet to LAN-B. First, use the first host address for the customer router interface connected to LAN-B switch. Second, use the second host address for the LAN-B switch. Make sure to assign a default gateway address for the switch. Third, use the last host address for PCB. Make sure to assign a default gateway address for the PC. So, next, for the customer router to LAN-B switch, we use a gigabit 0/1. So we go to subnet table and then copy for the first usable IP address at the second row, and then paste on the customer router gigabit 01 IP address. For the subnet mask, we use the same row as IP address before and then paste on the subnet mask. For the LAN-B switch, we copy from the same as IP address at gigabit 0/1, and then we paste, and after that we change at the back to 66, and then for the subnet mask we still use the same as subnet mask at G01, and then for the default gateway we copy from the IP address G0/1, and then for the PCB we use this last usable IP address. We copy and then we paste at the addressing table. For the subnet mask, we still use the same subnet mask as before, and then for the customer router, we copy and then paste at the same G0/1.
Going to guide on how to configure this customer router first before we configure other devices, and referring to the addressing table. So for the first step of step 1 is that we want to enable secret password, which is class 1 to 3, and then we will need to set the console login password to Cisco 123. So the function of console login password is to make sure that only the rightful owner of the device, of the laptop, have the access to modify or change any configuration of this router. So those who have this password will gain access to modify the configuration of the router. And then next we're going to change the host name of the router to customer router, and then we will configure gigabit 00 and gigabit 01 interfaces by changing the IP addresses and subnet mask according to addressing table that we already done earlier, and then we will enable them. And last but not least, we will save the current configuration of the router so that next time we don't have to set it up all over again because it's already saved in RAM. So let's move on. This is the interface that I already did. We can just simply delete the customer router. So I'm using a customer router. I'm using router 2911. First, we need to insert the module so that it will work. So to insert the module, we need to turn off the router first, and then as you can see, there are 4 slots here which starts from 0, 1, 2 and 3. So for the slot 2 and 3, I'm going to insert module 4ESW here, and then for slot 0 and 1, I'm going to insert 2T modules. So this is how it should look like, and then I'm going to zoom out. We're going to turn on the router to make it work. So you can just minimize the window because we're still going to work on it later, and then connect the cable just automatically. And for the router to ISP router, I'm going to use serial LTE cable. We're going to connect serial 000 to serial 010. So I'm going to change the name of this router so that I don't get confused, and it already referred to the topology given. So this is how it should looks like. So we can move on to the command line interface. So let's press enter to start. Alright, so first, as the question asks, we will need to set the enable secret password on customer router to class 123. I'm going to copy this password so it will be more accurate. So to set the password, first thing first, we're going to enable and then press enter. So as you can see, the symbol has changed and it already enabled router, which means we already enabled the router. And then we're going to go to the terminal mode by typing in configure terminal. Alright, so we're already in the configure mode, and then we need to enable secret, and then I'm just going to paste what I've already copied, which is class 123, and then we're going to enter it, and then there you go. So it's already enabled. And then next, we're going to set the console login password to Cisco 123. I'm going to copy this one as well so that will be more accurate. And then to enter the console mode, let's just simply type in line console 0. This is 0, not O, and then press enter. So we're already in the line mode, configure line. So just simply type in password and then paste what I've copied earlier, which is Cisco 123, and then press enter. So we type in login because we want this password to be set to when each time we log in to the CLI. So after we type in login, just press enter, and then we're already done. So this is how to set the console login password to Cisco 123. So I'm going to exit this mode because we want to do other stuff as well. So next stuff we need to do is to change the hostname, configure the hostname of the router to CustomerRouter. Again, I'm just going to copy this one, and then just simply type in hostname and then paste CustomerRouter. So what this will do is we will change the hostname for this router. As you can see, this is still router. Once you turn it in, enter, there you go. So it's the transition from router to CustomerRouter, from hosting router to CustomerRouter. And then let's move on to the next requirement that we need to do is to configure the Giga 00 and Giga 01. So we're going to do Giga 01 first, and then we're going to set the IP address, subnet mask, and then enable them. Okay, so we're going to do the Giga 00 first. So to do so, we're just going to type in interface gigabit Ethernet 00 because we want to configure the 00 first, and then just press enter. So we're already in the configure interface mode of this gigabit 00. So I'm going to type in IP address, and then I already have the addressing table here, so I'm just going to simply copy it and then paste here, followed by the subnet mask because the question asks you to do so. So just copy and then paste it. Alright, and so we just turn enter, and we already set the IP address. So we already did the gigabit Ethernet 00 interface by setting in IP address and also subnet mask. Next is we have to enable them so that it will work. To enable them, I will show you the command sheet, cheat sheet. No shutdown. So this is to enable the interface. I'm going to highlight. So this is the command, no shutdown. Press enter, and then there you go. So it is changed state to up. And then next we're going to configure gigabit 01, and then we will change the IP address and subnet mask, and then enable them just like giga 00. Just press enter when, and we're already in interface, where you can see it's already here IF. But because we want to change the internet for interface for giga 01, we're going to type in this command. Just change the letter 1 to 1 instead of 0, and then press enter. And then again exactly the same, but the IP address and the subnet mask would be different. Just refer to the addressing table. So I'm going to copy, paste the IP address, and then the subnet mask as well. So we press enter, and then just type in no shutdown to enable them. Alright, so gigabit Ethernet 01 is already changed. Next is, last but not least, we're going to save. So before we save, we need to do this command, which is we need to exit the configuration mode, because we're already done configuring everything that we need to do. So to do so, just press on your keyboard Ctrl Z, and there you go. We already logged out from the configuration mode. So we need to save this configuration that we've already did. So to save it, so this is the command: switch copy running config startup. I'm going to highlight this one. Just going to copy, and then just press enter. As you can see, the hash is still there, and then we're going to paste it, and then just press enter. So destination file name startup config, which means that this configuration is saved to startup config, which means every time you open the CustomerRouter CLI, everything is set up just like how we did just now, because it's already on the startup configuration. So press enter, and then there you go. That's how to solve to configure the CustomerRouter. So thank you for watching, and please stay tuned to watch the next 2 steps and then the last part.
So now we go to the step 3, part 2, configure the PC interfaces, configure the PC IP address, subnet mask, and default gateway setting on PC A and PC B. Next, we go to the PC A, desktop, IP configuration, and then we copy from the IP address at the addressing table before, which is 192.168.0 and 62. For subnet mask at the back, we change to 192. For default gateway, we use the same as IP address, but at the back we change to 0.1. Next, we go to the PCB. We go to the desktop, IP configuration, and then same as IP address at the addressing table, 192.168.0.126, and subnet mask at the back we change to 192. And then for the default gateway, we change to same as IP address, but at the back we change to 0.65.
I'm going to discuss about step 2, which is configure the two customers LAN switch. Configure the IP address on interface VLAN 1 on the two customer LAN switch. Make sure to configure the correct default gateway on each switch. On LAN-A switch, we will be using this IP address, which is 192.168.0.2, and the subnet mask is 255.255.255.192, and the default gateway is 192.168.0.1. So enter the LAN-A and click the CLI, and first of all enter the enable, and after that configure the terminal, and after that interface VLAN 1 and input the IP address, which is 192.168.0.66, and the subnet mask is 255.255.255.192. After that enter no shutdown, and after that enter exit and enter IP default gateway, which is 192.168.0.65. After that Ctrl Z, and after that copy running config and startup config, and the configuration done. So for LAN-B, we will be using 192.168.0.66, and the subnet mask is 255.255.255.192, and the default gateway is 192.168.0.65. So for LAN-B, enter the enable, and after that configure terminal and interface VLAN 1, and enter IP address, which is 192.168.0.66, and after that the subnet mask is 255.255.255.192. After that enter no shutdown, and after that exit, and after that enter IP default gateway, which is 192.168.0.65. After that Ctrl Z, and after that copy running config, startup config, and building configuration done.
Finally, we need to test and troubleshoot the network using the packet tracer. So we can use the ping command to test the network connectivity. So here is the question A. Determine if PC A can communicate with its default gateway. B. Determine if PC B can communicate with its default gateway. And question C. Determine if PC A can communicate with PC B. Did you get the reply? So here I will show you how to determine whether PC A can communicate with its default gateway. Firstly, click on the PC A and then click on the command prompt. Here you will type ipconfig and then you can see the default gateway address, which is 192.168.0.1. Then you can just type the ping command, and then you can just enter the default gateway address, which is 192.168.0.1. If you get a reply, it means that the PCA and the default gateway is connected. Next, here is how to determine whether PCB can communicate with its default gateway the same process as the PCA. Firstly, you click on the PCB and then you click on the command prompt. And then you can type ipconfig. And then you just enter the ping command. And then you can just copy this address of the default gateway, which is 192.168.0.65. And then you enter. If you get a reply, it means that the PCB and the default gateway is connected. Lastly, I will show you how to determine whether PCA can communicate with PCB. So, firstly, you copy the IP address of the PCB at the IP configuration. Here you can see the IP address, which is 192.168.0.126. And then you click on the PCA and then enter the ping command. And you input the IP address of the PCB, which is 192.168.0.126. If you get a reply, it means that the PCA and B are connected. So that concludes our discussion on Subnetting Address Internet Protocol version 4 using Packet Tracer. So thank you for watching.